All right, this is our final module of Unit 4, Earth Systems and Resources. So, Earth Geography and Climate, El Niño and La Niña. Our learning goals today are describe how ocean circulation affects weather and global climates, explain how mountains interrupt ocean airflow and cause rain shadows, and identify the causes and consequences of El Nino and La Nina. So, our first standard again is describe how ocean circulation affects weather and global climates. So, the oceans carry massive amounts of heat and affect climates on the continents. As you know, the warmer air is going to hold more water, and water has a high specific gravity. Just means it takes a lot of energy to heat or to increase or decrease the temperature of water. And so, being a big body of water, it's going to maintain a relatively stable temperature. The currents are driven by unequal heating, gravity, wind, salinity, and content location. As the sun warms up the equator, the tropical water expands to be taller than the middle latitudes. This height allows gravity to let the water flow away from the equator. The wind, deflected by the Coriolis effect, also drives surface currents from west to east, and currents rotate clockwise in the northern hemisphere and counterclockwise in the southern hemisphere in gyres. Ooh, sorry about that. So a gyre is a large-scale pattern of water circulation that moves clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. So this would be a gyre in the northern hemisphere, and in the southern hemisphere, it would go this way. Um, it's pretty interesting if you talk to somebody who's from the southern hemisphere, the drain in their bathtub or their sinks goes the opposite direction of ours, so counterclockwise, whereas here in North America, ours goes clockwise. So it's pretty interesting. As you can see, like the water gets warm throughout the middle of the day, and that causes it to expand. And when you're talking about, you know, the ocean, it's expanding quite a bit. And your book, I think, says 8 centimeters. It raises up, and then it will fall towards whatever side, just like the top of a triangle. If you had like an egg here, it's going to fall to one side or the other. So the water again heats up here because of the sun, and it's going to fall to either side, bringing more warm water either north or south to that middle latitude areas. As surface currents move away, some of the water near the bottom moves upward in the process called upwelling. So upwelling is will bring nutrients and things like that from the ocean floor. Um, and it's really good for our producers that are living in the zone where sunlight will peek through there because it brings them additional nitrogen and carbon and phosphorus and things like that to make DNA and do protein synthesis and all that kind of stuff. So upwelling is actually pretty important, and that's as the surface currents move away, it's dragging more water with it, and so the bottom of that ocean floor is coming up, and that's called upwelling. That's pretty easy to remember. When the surface waters and deep water mix, this causes a thermohaline circulation, which moves heat and nutrients around the globe. So just it's a big cycle, right? So the step one, the warm water flows from the Gulf of Mexico to the North Atlantic, where sometimes some of it freezes and evaporates. So we're here, so it's moving from the Gulf of Mexico up to the Northern Atlantic, and then it's going to freeze and evaporate or form our ice caps. Okay, the remaining water now saltier because the water has frozen, so the salts had to be coming out of that frozen water because salt in water will not freeze as easily as just regular water. So that salty water that's now denser sinks to the bottom of the ocean and it's going to be below that warmer water because warm things rise, and it's going to travel back down here to the Antarctic, and the cold water travels along the ocean floor, connecting the world's oceans. So we're on this hemisphere in between at the Atlantic Ocean, and it's going to be traveling down. As it's cold, it's going to stay under that warm water that's being warmed up by the sun on the equator. Since it's colder, it's going to be closer to the bottom. And then the cold, deep water eventually rises to the surface and becomes shallow current water that's being warmed up. And it travels and then just does that whole cycle again. So again, starts warm at the top, gets a little colder and saltier. That salt water is pretty dense. It's going to sink towards the bottom of the ocean, move down in this direction, and as it comes into its patterns here, it's going to move to the surface and get warmer. Scientists are concerned with global warming could affect the thermohaline circulation, so increased air temperatures accelerate the melting of glaciers, which you guys are already pretty familiar with. This would increase the water that is less salty in the northern hemisphere. An excess of freshwater in the northern Atlantic could lead to a shutdown of circulation, which would prevent the transfer of warmth from the equator to the north. So they're concerned that the salt will be more diluted in the water and it will cause uneven heating, which means the water is not going to move as much. So this is like the same process if you've ever boiled water and you have it not sitting on the burner all the way and like macaroni noodles in there. Those macaroni noodles are going to go in a circular motion. They're going to heat up, cool down, submerge, and come back. And so that's what they're worried about is now that the water is getting warmer, there's going to be more salt in it. And so it's not going to cool down as much. It's just going to stay at the surface and not bring up that nutrients and things like that. So now we're on our second standard. Explain how mountains interrupt ocean airflow to cause rain shadows. Some effects on weather and climate are not global but local. Around mountain ranges, air moving inland from the ocean contains water vapor. As ocean winds move up the windward side of a mountain, adiabatic cooling and air moisture is lost through precipitation. Once wind moves down the leeward side, the wind has become warm and dry. It is typical to see greener, more lush vegetation on the windward side and drier and even desert-like conditions on the leeward side. This phenomenon is known as the rain shadow. So I actually have pretty good experience with this, but I'll go over this diagram pretty quickly. So this would be the warm ocean, and the prevailing winds are going to move up, and it takes a lot of heat and energy to get over the tops of these mountains, and so a lot of your precipitation stops here, and your colder, your moist, warm air doesn't go as far because it starts to cool down because it gets expanded, and so the volume of it increases, so the heat decreases, and then it's going to start to fall back down and get more arid and dry. When I worked at a summer camp in New York, I was in the Adirondack Mountain Ranges, which is about 4 hours from New York City, but we're a little bit closer to the coast. We would see this all the time, and so we would be on like this side of the mountain, or we'd be kind of around here, but we'd see our storms like all around in like these areas, like clouds, and this would be like mainly every other day. But whether it made it over the mountain was pretty slim, and so when it finally did make it over the mountain, you knew it was serious, and we had to kind of close up shop for the day and be stuck in our cabins. But again, it just takes a lot of heat, or excuse me, a lot of energy to make it up over those mountains. And as the wind moves up, it just gets too heavy to keep going. It loses its precipitation and then starts to condense, expand and get cooler. And then it makes its way over the mountains. And so this is also, you can see this in Colorado going from west to east. And so on the west side of the mountains, you don't get as much of the air dry, whereas on the east side, this side of the mountains, you see more of a desert-like climate the further south you go to, and it's because of this rain shadow. Okay, finally, we're on 23.3. Identify the causes and consequences of El Niño and La Niña events. So, El Niño, Southern Oscillation, is a reversal of wind and water currents in the Southern Pacific. and La Nina follows El Nino event. Trade winds in the South Pacific reserve strongly, causing regions that are not hot and dry to become colder and wetter. So ocean currents can shift when there's a shift in prevailing winds and currents influencing global weather. So um, going back a few slides, these can change based off of other factors such as getting warmer or colder or oscillation or the Coriolis effect, excuse me, um, and things like that. So those are not tried and true 100%, but that's generally how they go, but they can change. And so ocean currents can shift. There's a shift prevailing winds and currents influencing global weather. And the South Pacific trade winds and the Coriolis effect cause water to flow from east to west every 3 to 7 years. So a periodic disruption, and a tropical current moves into the opposite direction. This is called El Nino Southern Oscillation, named duly to the phenomenon occurring near December 25th, the Christmas holiday. And so you can see here what happens is during a normal year, everything is going in one direction. And then during an El Nino year, something will happen or the winds will change, the current will change, and it'll go back this way. And so if you see this little islands right here, this is Hawaii. And so they hate this because there's like a 2 day spot where the air is just stagnant, and they don't have air conditioning and things like that because they live in a pretty tropical paradise where it doesn't get too hot, too cold, and there's always kind of a breeze going. But during like the 2 days of transitioning, the air is just stagnant, and so they hate it. And then after that 2 days, the air starts to go back this way, and it's a good time. And then it'll revert back, and they're miserable for a couple of days. Just kind of an interesting little tidbit. So some effects of an El Nino include the trade winds moving from South America are weakened or reversed. So our cruise ships and things like that delivering goods and services might be delayed. The shift suppresses upwelling off the coast of Peru, so they're not getting as much nutrients off the bottom of the ocean. Productivity and fish populations are reduced off of South American coast. Okay, we get that. There's not as much vegetation getting as much nutrients, so that affects the food chain, kind of a trophic cascade. The southeastern U.S. gets colder and wetter conditions than normal. Northern U.S., Canada, Southern Africa, and Southeast Asia become unusually dry. Crop production in these countries drop and food shortages occur. Again, because you're not getting that upwelling, you're not getting that rain, or the rain's going the opposite direction. So all those things make sense. After an El Nino, winds typically reverse back to normal, but may be stronger than usual. This phenomenon is known as a La Nina, meaning those regions that were hot and dry now become cool and wetter. So that's when they see a lot of those rains, and that'd be a periodic disruption, like what we've talked about in earlier modules. So that wraps up Unit 4. Let me know if you have